Hey everybody, just taking a look at our Chapter 9 reviews, questions number 12 and 13, the free response questions. So in this first question here, number 12 we're taking a look at, we're trying to understand if there is a difference between how many words people can remember when they've had a cup of coffee versus when they have not had a cup of coffee. Now before we get into the actual test, I want to take a look at question A, which is saying, does it make sense to give everybody no coffee on Monday and then give everybody coffee on Wednesday? And I think that's a pretty obvious thing that we should not do that, because in that situation, the fact that it's Monday would be considered a lurking variable and therefore affect the number of words that you remember. Generally, people are, a little bit more tired on Monday, a little bit less motivated, but by Wednesday they're kind of in the flow of things. So what you want to do instead is you want to randomize the order in which they get the coffee or don't get the coffee. In other words, you take each subject, you flip a coin. If heads comes up, that means they don't get coffee on Monday, but they do get coffee on Wednesday, and vice versa if you get tails. So that's question A. But question B is the one that deals with the significance test. Now, the first thing you want to recognize is that there are two columns of data. There's a column of data for no cup of coffee and a column of data for 1 cup of coffee, and they're matched by the student number. So that's a big indication that what you're looking at is a paired t-test. So the very first thing you want to do is you want to actually subtract the differences. Now I subtracted 1 cup minus no cup because, as you see, that ended up giving me more positive values. Actually, there are no negative values in this case. Once I have that data of the difference, I throw that into L1, my list 1, and I get my summary statistics using the 1 variable statistics. I get a mean difference of 1, standard deviation difference of 0.8165. Then I can go ahead and run the test. Now I've abbreviated a little bit here because I didn't have enough room to show you all, but I'll explain all the steps along the way. In the state step, the parameter is mu sub d, the true difference in memory score between 1 cup and no cup. HO, as always with a paired t-test, is that mu sub d equals 0. HA is that mu sub d is greater than 0. How do I know greater than? Because the question says improves memory. Therefore, when I do 1 cup minus no cup, I should have a positive value. Alpha is 0.05 because they didn't give us any reason to use anything else. So as the plan step, told you it's a paired t-test. SRS, well, now this one's a little bit interesting here because it's not a simple random sample of individuals. Therefore, we're not going to be able to generalize to the population. But as long as they've randomized the order in which you get the treatments, you can tell whether there is in fact a difference for this group. Now that's kind of a wordy response, but there's 2 parts to randomizing. As far as independence, must assume there's at least 100 students, and normality. Well, I drew a little box plot down here, and it's a little different than most box plots because there's no apparent whisker out to the minimum, whisker out to the maximum. And what that tells you is that the minimum is the Q1 and the maximum is the Q3. Now as you look at it, it's kind of a little bit weird, but there's no outliers, there's no crazy skewness, so no reason to doubt the normality. So then we can go to the do step. It's a t-test statistic that we're finding. Here's our formula for finding that t. This is plugging in all of the values, and we ended up getting a t of about 3.873. Now this is a one-sided t-test, so to get the p-value, we're going to use t-CDF. Lower is 3.873, upper is 999. Degrees of freedom are 9, and why is it 9? Well, because we have n minus 1 degrees of freedom, and there are 10 in the sample. That gives us a p-value of 0.0019, which tells us that we will reject HO because p is less than alpha. Therefore, we do have sufficient evidence to say that coffee does increase words remembered. All right, and that covers everything for number 12. Let's take a look at number 13. Okay, so in this problem here, we know we're looking at means. So we know, and there's no pair data here, so we know we're looking at a 1 sample t-test for means. In the state step, the parameter we're talking about is mu, the true mean amount of money spent on food per week. The claimed value is $158. We want to know if that differs from our value here, and our alpha is 0.05. As far as the conditions, we're told it's an SRS. It's safe to assume that the population is at least 500, and because the sample size is 50, our distribution is approximately normal by the central limit theorem. Then we can go ahead and get our test statistic of plugging in here x bar minus mu divided by the standard deviation of x over the square root of n. Plugging in our values, so you get a test statistic of about 2.48, 49 degrees of freedom, again n minus 1. Here's a diagram showing what's going on, and it's always a good idea to do the diagram because we can clearly see here that this is a two-sided test. So when we go to get the p-value, we have to make sure to multiply by 2. When we do so, we get 2 times TCDF of 2.4749 up to 999 with 49 degrees of freedom, and that yields a p-value of about 0.0168. Now because the p is so low, in fact p is less than alpha, we reject the null hypothesis. Therefore, we do have convincing evidence that the weekly amount on food spent is not $158. All right, so that's it on those two questions. Hopefully you did pretty well on those. Take a look at some more review, whether you're looking through the textbook for practice problems or going through the study guide I gave in class. Do what you need to do to get yourself ready for the test tomorrow, and we'll see you then.